What I'm studying here at Colorado State University is the importance of snowmelt to generating stream flow in different climate types. In our field research, we have a network of watersheds that we monitor along an elevation gradient from low elevations here in the Front Range and out in western Colorado up to high elevations above 10,000 feet where we have deep snowpacks. Down in the valley we have a variety of different instrumentation that's monitoring soil moisture, snow depth, air temperature, rainfall, etc. And with all of our field sites that are at different elevations throughout the Rockies, we try to locate them in the valley bottom close to the stream so that we have kind of some uniformity.
I'm originally from Houston, Texas, so being able to come out here and do all the hiking, go to all our data sites, get to learn a lot about Colorado and see some beautiful places.
10, 11, and 7 for 40 meters. So we get out to the sites about once a month. Some of that work deals with downloading data off of the variety of sensors that we have up there that monitor snow depth, rainfall, soil moisture, and stream flow, the amount of water flowing within a stream. We've been using different methods. We've been doing remote sensing of snowpacks and looking at how various variables from those snowpacks correlate to water resources across the western U.S. We've also been doing in-depth soil moisture modeling.
Oh man, yeah, these guys might still be frozen. These are our little PRS probes. They simulate plant roots, basically. So we're looking at the snow depth, which translates to how much snow melt, which then translates to how much nutrients are in the soil water.
For snow depth, we use trail cameras, which can be set to either track wildlife as it's passing by, or you can set it to a time-lapse setting, which is what we do. We set them to about an hour increment, so we get a photo which is focusing on a metered pole, so we can see how deep the snow is at every one of those hour increments, and we can stitch those together to create time lapses so we see how snow accumulates and melts out.
This is known as a canometer. That is actually the scientific term used in the field of snow hydrology.
In order to measure the snowpack density and the ultimately the water equivalent within the snow, we have a couple different containers of various volumes that we insert within the snow to extract a snow core and then measure both the depth and the weight of snow.
About 915, looks like.
The work that we've been doing so far is not necessarily predictive. What we've been doing is kind of reducing the uncertainty or increasing our understanding of how snowmelt overall affects soil moisture and stream flow generation across the western U.S. What we're focused on is just gaining a better understanding of under different conditions of snow and in future periods of snow loss, how will water resources kind of respond.